Good morning students. Today we are going to discuss about covalent bond. Do you know what is covalent bond? Have you heard about it before? Covalent bond. Can any one of you tell what is covalent bond? Yes, please.
Bond formed by the sharing of electrons.
Okay, very good. So what is covalent bond? It is a bond which is formed by sharing of electron. So can we say there is only just one kind of covalent bond, or we can have multiple types of covalent bond? Do you have any idea? Anyone? Yes, please try.
So there are multiple types of covalent bonds. First is single bond,
Okay.
second is double bond, and third is triple bond.
Okay, very good. Sit down. So in types of covalent bond, we are having how many types of covalent bond? We are having 3 types of covalent bond. What are the types? The first one is single covalent bond. Second one is double covalent bond. And the third one is triple covalent bond. Do you know how the elements will be able to form sometimes single covalent, sometimes double covalent, and at different times triple covalent bond? How do we choose that an element needs to form a single bond, a double bond, or a triple bond? Do you know how can we decide? Anybody, do you have any idea related to that? So we will see just a video about the covalent bond. You see, this video will give us idea about. So here we are having a boy who is playing with a ball, and now what he will do? We will just watch in this video. Do you have any idea about what is a noble gas? Anyone? Please try. Yes?
The atoms whose valence shell is completely filled with stable amount of electrons. Either its duplet is complete or its octet is complete.
Okay, sit down. So what is a noble gas? It is any type of element which is having a completely filled outermost valence shell. So here we are having an example of a noble gas. See, what is noble gas? This is the inner shell of the noble gas, and this one is the outer shell of the noble gas. If we are having helium, in its case we have a complete duplet, whereas in case of all other noble gases, what do we have? We have a completely filled octet in its outermost valence shell. So see the video ahead. We just discussed about covalent bond. Why do elements make covalent bond? Do you have any idea? Because they want to become stable. Just like who? Just like a noble gas. As the noble gas has completely filled outermost valence shell, in the same way, all the elements, either by sharing their electrons, they want to achieve completely filled octet. How we will achieve completely filled octet? If we are not having 8 electrons, what we can do? Either we can take from someone or we can share the electrons which we are having with us. So now we will see two elements which will share their electron so that they can have a complete octet. Here first type what we discussed, the single covalent bond. Here we are having two halogen family atoms, that is fluorine. What is the number of electrons present in the outermost valence shell of fluorine? 7. So each fluorine is having 7 electrons in its outermost shell. The second fluorine is also having how many electrons? 7 electrons in its outermost valence shell. So how many extra electron do we need to complete the outer octet? 1. So this fluorine is sharing a single electron, whereas the another fluorine is also sharing a single electron to complete its octet. So when any element shares 1 electron each during the formation of the covalent bond, what is the type of the covalent bond that is formed? It is single covalent bond. Now we will see about the double covalent bond. The same example for chlorine molecule, which can be used in case of any halogen atom or any halogen element. What they will do? They will share the outermost electron to complete their octet. In case of halogens, how many electrons are needed? Just one, as they have 7 electrons in their outermost valence shell. So just by sharing 1 electron, what they are forming? Single covalent bond. Whereas, do you know what is the atomic number of oxygen? Anyone? 8. So what will be its electronic configuration? 2 and 6. So if you are having 6 electrons in your outermost valence shell, how many more electrons are needed to complete your octet? 2 more electrons. So now in this case, what we will do? See this video. What we are having, in case of oxygen, each oxygen is having how many electrons? 8 electrons, out among which the 6 are present in its outermost valence shell. So what will an oxygen do? The oxygen will search another oxygen atom or a molecule, and what it will do? It will share, you can see they are sharing how many electrons in total? Total 4 electrons. So one bond is formed by the combination of how many electrons? 2 electrons. So what is the total number of bond that will be formed in this case? It is a double bond, and this sharing double bond will be called what type of covalent bond? Double covalent bond. Same one more example which we had discussed, the type, that is the triple covalent bond. In which element do you think can we get a triple covalent bond? Nitrogen. What is the atomic number of nitrogen? Any guesses? 7. So what will be the electronic configuration of nitrogen? 2, 5. So each nitrogen is having 5 electrons in its outermost valence shell. So how many electrons are needed to complete the octet? 3. So each nitrogen will share 3 electrons from its outer shell to complete its octet. So now after sharing 3 electrons, how many electrons are shared? 3 from the first nitrogen and 3 from the second nitrogen. So the total number of electrons being shared is 6. Single bond is formed by how many electrons? 2. So in case of 6 electrons, what will be the number of bonds? 3. So this is an example of what we can say, triple covalent bond. Okay, let's come back to here. Single covalent bond, double covalent bond and triple covalent bond. Do you remember what was the name of the element which we have seen to form single covalent bond? Chlorine. How many electrons were shared between the chlorine?
2.
This is the electron of the first chlorine and this is the electron of the second chlorine. By sharing these two, what kind of bond we were forming? Single covalent bond. What is the example for the double covalent bond where we had formed double covalent bond? Oxygen. So in case of oxygen, these are the 2 electrons of the first oxygen and these are the 2 electrons of the second oxygen. And these in common will, what do they form? They will form a double covalent bond. Example of triple covalent bond was nitrogen. So here we will have the first nitrogen having its 3 electrons and we are having a second nitrogen which will have its 3 electron, and these 3 electrons will form a triple covalent bond between the 2 nitrogen atoms. So are you clear about what is a covalent bond and what are the types of the covalent bond that exist? Okay. Now we will study about the fission of the covalent bond. That means when we break a covalent bond, what are the possibilities that we can get after breaking the covalent bond? See, we are having a video, you can take its help.
Fission of covalent bonds.
See, the word fission means breaking. If we break any substance, it is called fission. Anything which breaks into one or more parts is called fission. So what we will have here?
The nature of an element indicates the chemical bonding between the atoms of the element. Chemical bonding is the attraction between the atoms of an element. This attraction binds the atoms together. Let's take a look at the chemical bonding in a chlorine molecule. A chlorine molecule is composed of 2 chlorine atoms. The atomic number of chlorine is 17 and its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. The electronic configuration of chlorine indicate.
See here how many electrons are there in chlorine outermost valence shell? 7. So how many electrons will be needed? 1 more. So when we will share 1 more electron, see, these will share this electron. 1 electron from the either side will be shared between these both. What kind of bond will be formed when we will share one electron each between the chlorine? Single covalent bond. So this is a single covalent bond. Now what we are going to discuss? We are going to discuss how we will break this bond and what will be formed upon the fission of the following chlorine bond. Let's see what we are doing.
It's that 7 electrons are present in the outermost valence shell of a chlorine atom. To become stable, the 2 chlorine atoms share 1 electron with each other and form a bond. Theoretically, the electron bonding between atoms is indicated with a dash. Such a chemical bond, which is formed by the sharing of electrons between 2 atoms, is called covalent bond. Here, you can see the covalent bond in a chlorine molecule. A chemical reaction takes place when the bonds between the atoms break. This phenomenon is called breakage or cleavage of bonds. The result of the reaction is the formation of new bonds in the products. Let us learn about the breakage.
See, now we are discussing about breakage or fission of the bond. What do you understand by the term fission, or we are having breakage? What do you understand by breaking something or fission of something? Any idea? Tarun? Breaking. That means we will break something. See what we are having? We are having 2 AA atoms are combined with each other by the help of a bond. Here we are having another element which is combined with the help of a covalent bond. What we will do? We will break this bond from the center. Why we are breaking the bond? So that any new compound can be formed. You can see one from here, the another one from here are combining to produce a new compound. So why does the breaking of bond takes place? So that it can lead to the formation of a new type of compound, whereas it can gain more stability as compared to the previous bond which was formed. So now we will see the next type here, how this bond cleavage takes place.
Let's look at the method.
So what are the 2 types of bond cleavage which we will see? The first one which we will see will be heterolytic fission. Heterolytic fission. And the second one which we will see will be homolytic fission. Do you have any idea what does the word hetero means? Different. Hetero means different. So this word refers to different. And what does the word homo means? Same or similar. So what we will have different or what will be similar among the following? Do you have any idea? See, we are having a compound that is CH3Cl. Do you know what will be the name of this particular compound CH3Cl? Any idea? What will be its name? Methyl chloride. Or can we say, can it have the name of chloromethane? How do we write the name? We write the name of the suffix before, or we can say we write the name of the substituent which is attached to the carbon chain before the root word of the longest parent carbon. So how many carbon it is having? It is having just 1 carbon. So we are writing methane for that. And it is having a chlorine group attached to it, so we are writing the word chloro before the name of the methane. So in case of heterolytic fission, what do? we see that one side we are having chlorine, other side we are having carbon. Do you know about the concept of electronegativity? The ability of the elements to attract the shared pair of electrons towards itself. So we are having one electron of the carbon and we are having one electron from the chlorine which is being shared. So in this case, what we will see, the electrons will shift towards the chlorine. Why they will shift? Because the chlorine has high electronegative value. So what will happen? The electrons will shift towards chlorine. Chlorine will acquire a charge that is delta minus. As the electrons will shift towards the chlorine, so what will be the charge on the alkyl group? It will be delta positive. Now you can see the same video.
Methyl chloride molecule. A covalent bond is present in a methyl chloride molecule as a result of the sharing of electrons between the methyl group and the chlorine atom. When this covalent bond undergoes cleavage, due to the higher electronegativity of the chlorine atom in comparison with the methyl group, the shared pair of electrons moves towards the chlorine atom. This type of cleavage is called heterolytic cleavage or heterolytic fission. The result of this heterolytic fission is that the methyl group attains.
See what we are doing here? We are breaking this bond between the methyl group and the chlorine. So as a result of this, what is the chlorine gaining? Chlorine is gaining a negative charge, whereas this alkyl group or the methyl group is having a positive charge. Carbon having a positive charge is called, what can we say? Any element. Have you heard about ions? How many types of ions are there? Two types. One is positively charged and other one is negatively charged. So what do we call the positively charged ion? Cation. And what do we call the negatively charged ion? Anion. So if we are having a carbon which is having a positive charge, what we will call it? Carbon plus cation. So it will be called carbocation. So whenever we are doing heterolytic fission of a covalent bond and these shared pair of electrons shift towards a higher electronegative atom, leaving an sextet of carbon with, we can say, sextet of electrons. Do you understand what is a sextet? As octet means a complete 8 electrons in the outermost valence shell, sextet refers to 6 electrons in the outermost valence shell of carbon. Okay? As we were sharing, what happens? Now the carbon which the electron it had shared is now with the chlorine. So what we will get? We will get a carbon which is having a positive charge and it is called a carbocation. You can see ahead in the video.
Attains a positive charge and the chlorine atom attains a negative charge. The positively charged methyl group is called carbocation or carbonium ion. In a heterolytic cleavage, if the shared pair of electrons moves to...
Now we will see the second type of movement. Here this Y group which we are having, this Y group will be more electronegative or less electronegative as compared to carbon. Last time we had chlorine which was more electronegative. So this time this Y group, it will have less electronegativity as compared to carbon. So now what will happen? If carbon is more electronegative, the electrons will shift towards whom? Towards the carbon. Now when this bond will break, this will lead to a type of heterolytic fission in which this group will have a negative charge. Why it will have negative charge? Because it is acquiring the extra electron of the other group, whereas the other group will occupy a positive charge as it will lose its one electron to the carbon. So we had discussed just now about the two types of the ions. What was in the one having the positive charge called? Cation. Now this is having a negative charge. What do we call it? So carbon having a negative charge will be called carbon plus anion, which will be called carbanion. Did you understand what is carbocation and what is carbanion? When in a heterolytic fission, the positive charge is on the carbon, it is called carbocation, and when the negative charge is on the carbon, it is called carbanion. Okay? So after this, we will see one more type of cleavage, that is homolytic cleavage. Do you know what is homolytic cleavage? We just discussed hetero means different. Then what will the word homo means? Same, similar. So we will have a group, that is we can say R-R. What does this R refers to? It refers to any alkyl group. So this is also an alkyl group. What will happen now? If we are having two similar groups attached to each other, we are having the first alkyl group and we are having the second alkyl group. Let's see in this type of fission of bond what happens.
Now let's understand the homolytic fission of covalent bonds with the help of ethane as an example. A covalent bond is present between the carbon atoms in an ethane molecule because these atoms share electrons. When the covalent bond between the methyl groups undergoes cleavage, due to the equal electronegativity of both the groups, each electron moves to the respective methyl group. This type of cleavage, in which each atom or group separates out with one electron of each of the bond electron pair, is called homolytic cleavage. The cleavage results in the formation of neutral species containing unpaired.
See here what we are having in this case. So now what we are doing? We are just distributing. Last time in heterolytic fission, we were sharing all the two shared electrons to any single species. Now we will share the electrons in equal proportion, or we can say equally. This we can do. Here what we can do is we will share it equally. So one bond is formed by the combination of how many electrons? 2 electrons. So you can see this, a new type of arrow is being drawn to explain the movement of electron. This arrow having just a single half, it is called fish hook. What does fish hook means? It just represents that a single electron is being transferred to a particular group or a species. So when we transfer a single electron to the each alkyl group, the species formed is called a free radical. What do we call it? Free radical. So we will now conclude what we have studied till now. So we will get to, we started with the type of the covalent bond. What were the types? Single covalent bond, double covalent bond and triple covalent bond. In single covalent bond, 2 electrons were shared to form a single bond. In double covalent bond, total 4 electrons were shared to form a double bond, whereas in triple covalent bond, total 6 electrons were shared to form a triple bond. After this, what we show? After this, we had fission. What does the word fission means? Breakage, or we can say cleavage. How many types of fission did we study? Two types. What were the types of the fission? First one was homolytic fission, and second one was heterolytic fission. So, in homolytic fission, what was the species formed called?
Carbon.
No, in case of homolytic, when we were equally distributing one electrons to both the species, what was formed? We had free radical. What is a free radical? Any group having a single electron present in it. Whereas in case of heterolytic fission, we had two types of ions formed. One in which the carbon was having which kind of charge? Positive charge. And in another one, the carbon was having which kind of charge? Negative charge. The carbon having positive charge was called carbocation. And the other one in which the carbon was having a negative charge is called carbanion. So is it clear till this point? Okay, so let's conclude the class. Thank you.